Hello, everyone. I'm Dongsheng from NVIDIA. Today, I will present my DVCon paper, Discover Over Constraints by Leveraging Formal Tool. This paper proposed a new solution to over constraint detection by the formal tool. The presentation is structured as follows. The first is our introduction to the over constraint problem. Then is the introduction of random space, which is the basis of our solution. Then is our technical solution. We propose to use formal tool to discover our constraints. And then is the conclusion of this paper. Okay, let's get started with the introduction. Constraint random is a dominant and powerful stimulus coverage generation methodology. One of the most challenging problems of CRT is over constraint. Over constraints are constraints that are too narrow, ruling out certain legal input scenarios. So, what if over constraint happens? It will cause RTL bug escape and project schedule sleep. Traditionally, verification engineers rely on code review or simulation with coverage to find over constraints. But this workflow is very time and resource consuming and does not work very well. We proposed to use formal to identify over constraints. With formal, we can report random variables reachable space, identify unreachable expressions in constraints, and report unreachable bins in stimulus coverage. With the help of these reports, we can identify over constraints in a short turnaround time during the constraint composition stage. Before I introduce our technical solution, I would like to talk about random space, which helps us to understand the over constraint problems in depth. A random variable's random space is a feasible region. Let's satisfy all constraints on this variable. Take the constraint in this finger as an example. We can get its random space by a 3D table. After we get random space, we can check if the variable is over-constrained or not by comparing the intended space against the random space. Once we get a list of over-constrained variables, we can discover over-constraints by a simple analysis of constraint expressions. But what if a complex constraints network with many constraints and variables? It is impossible to manually think out a variable's random space. We should rely on a tool to exhaust a variable's random space. The first tool that comes to mind is the random solver, but it is very inefficient to search all random possibilities. And then we find formal. Formal is good at solving reachability problems, but formal cannot understand the random constraints directly. We should convert random constraints into formal readable, and then we can use formal to explore the variable's random space. The left finger described our workflow briefly. we started with a test command, and then we use Synopsys UCLI to generate a random constraints database. Okay. And then we convert random constraints and optionally seamless coverage into formal readable. After that, we can run formal, and the formal will generate formal report and a coverage database. When the output of formal various constraint reports will be generated, the reviewer can use these reports to find over constraints easily and quickly. In the right finger, we list a convert table from SVA random constraints to SVA properties. SVA property is the format of constraints in informal world. From this table, we can see that inside list, if else constraints are supported, unit are ignored, unit constraints are unsupported. So before, soft constraints are just simply ignored. Okay, let's take a look at our generated constraint report. We generated 3 constraint reports. The first one is unreachable code report. Formal can help to prove the reachability of constraint expressions. These unreachable expressions are sources of over-constrained or under-constrained stimuli. Let's take this. Let's look at this example. The if condition A plus B greater than F is unreachable because A and B are all 4-bit variables. Then arrow is over-constrained. Since arrow equals 1 is unreachable. The second one is a random space report. It visualizes random space. Unreachable space will be marked as red, and the reachable space will be marked as green. We developed a smart algorithm to divide random variables into 2 categories. Enum-like variables with all random possibilities, and continuous variables with a min-max range. Reviewers can check variables random space with the design spec requirements to find over-constrained variables quickly. The third one is the unreachable stimulus coverage report. User-defined stimulus coverage cover point can be optionally added as random state targets. These cover points can fit into formal, and formal will report all its reachable bins. The reviewers can judge whether those unreachable bins are over-constrained cases or just we can simply weave it in a weaver. Let's take this as an example. The cross bin the cross bin mod the cross bin mod A equals 0 and mod B equals 2 is a unreachable bin. And from formal, we can find that from formal we can find that we have an over constraint expressions. Okay. Okay. Finally, let's switch to our conclusion. We proposed a new solution to our constraint detection by introducing a formal tool into the simulation world. It creates a working model with the speed of right turnaround from constraint directory to report. In previous flow, we started from test creating and then coverage regression, and finally to coverage report analyze to find our constraints. Now we can run our tool to get the constraint reports in hours and discover all our constraints from this report. Okay, this is my presentation. For any questions, please contact me through my email. Any questions on this paper are welcome. That's all. Thank you. Thank you, everyone. Bye.